My name is Tomasz. I'm working as a solution architect at AWS, Amazon Web Services, and the topic of this presentation will be the serverless, how to build application using this approach and using artificial intelligence in today's world. This will be quite unique session, I would say, because I have got some slides, but it will take about 50 minutes, to go through the slides, and then we will spend about 45 minutes, and we'll build the application, okay? We'll try to build two applications, we'll see if we will make it, and after I will build it, I will ask you to test it, okay? So I really need your help there, and I hope you will help me. So guys, serverless. Serverless is one of the coolest trends which we see in IT currently. And if we would look in the past how we used to build application, 10, 15 years ago, and I know that some people, some companies are still building applications like this even today. We were using this monolithic approach. We were deploying the whole application, the whole system on a single server, and when we wanted to communicate with other components, other applications, we were using heavy technologies and protocols like XML and SOAP. Then, after a couple of years, we started breaking those applications into smaller parts, which we started calling microservices. There are different reasons why we started doing this, but more or less, also some of the reasons is that we started using new technologies like REST and JSON. So suddenly, we don't have this one big application, one big system, but we have got multiple small applications, those microservices, which exchange some kind of information. And this is more or less the way how we are building applications in most of the companies currently. At least we are trying to. And also the new change for us, for developers, was cloud. Suddenly there is a cloud, and in the cloud we have got some cool functionalities, so we don't need to do everything from scratch. We can start using database, some kind of storage service, and we can just consume it. Still, we have got our microservices. This is our business logic, thanks to which we glue those services which are provided by the cloud and also our microservices. But then we started breaking those microservices even further, and we started calling those things function. Some people call it function, some people still call it microservice, some people call it nanoservice, but the objective will be the same. And the point here with this function is that if we are not using them, they are sleeping, okay? So we are not paying for them. And if there will be some kind of invocation from outside, like HTTP requests, they will wake up, they will do what we have asked them to do, and then they will just go sleep again. And this is one of the objectives of serverless. And let's take a step back, and if we would look at the cloud, what very often I'm saying to developers, to companies, is that the cloud is Lego blocks, okay? We are going to the cloud not for a server. We are going to the cloud to choose those Lego blocks, thanks to which we'll build our application faster. And of course, there is this one single Lego block, which is a server, and we can treat cloud as just a data center. And we will build our application, maybe quite fancy application using servers, a lot of them. But maybe, maybe there is an easier way, maybe there is a better way. And, yes, there is a server, but there is also a Lego block for example, for Elasticsearch. Maybe we are doing some kind of big data project and we need Hadoop. Maybe we need to have some kind of database, so on, so on, so on. And this is the cloud. So those are those services, those Lego blocks, where we go to the cloud, we choose those Lego blocks, and based on this, we build application, system, and so on. So if we would look at the cloud, we would see that there are those cloud services. And for example, there will be this EC2, which is a server in the cloud. But after a couple of years, when people were using the cloud, they started saying, okay, but I don't want to manage infrastructure. I want to have, for example, a database, and I don't care about the server. So inside of this group, we have got something which is called a managed service. And for example, here we will have got something which is called RDS, which is a managed database. But then people started saying, okay, I don't manage server here, but I still see it. I still see that this server is small, big, medium, and so on. I still need to think about the scalability and so on. So inside of this group, we have got something which is called serverless. And inside of this group, we are saying, dear cloud, I don't want to think about the infrastructure. I don't care. I want to focus on my business. I want to focus on my application. Here is the database. Here is my microservice. Here it is, manage this, and I just want to use it. And why this serverless approach is so popular now? Because when we are building application, we want to build new Netflix, new Spotify. We don't want to manage infrastructure. So we have got this development phase. At the end, we are ready to show the world our application, but we can't go for production because there is the boring stuff about which we need to think, How many servers do I need? Who will be managing them, and so on. Finally, we answered those questions. Do we have got go live? Everybody are happy. We would like to work on new functionalities, but we can't because there is even more boring stuff which need to be done regarding this application. Still, somebody will need to patch this application, those servers, every month, and so on. So this is the quote from CTO of Amazon, which once said that there is no server is easier to manage than no server. So in short, most of the companies now try to avoid managing the infrastructures. They want to focus on applications, on the systems which they are building. And one of the most popular, if not the most popular, serverless service in the cloud will be Lambda. And Lambda will be this function, this microservice, which we deploy in the cloud, but we don't think about infrastructure. And in short, Lambda will be something like this, that we take our code, it can be written in a couple of different languages, we are just throwing it to the cloud and we are saying, dear cloud, manage this. This is the code which I've written, this is my business logic which I want to use. So there's a couple of different rules regarding serverless. And first rule is we don't want to manage infrastructure. We don't care about servers. The second thing is it needs to be highly available, out of the box. Because with the cloud, it's not rocket science to build applications which will be highly available. We can spin up servers in 2 data centers, and our application is highly available. With serverless, we don't want to do it because it needs to be out of the box. We don't care. We throw our microservice, our function, and this is the objective of the cloud to make sure that this is highly available. In AWS, we have got something which is called a region. And a region is a collection of the data centers. So for example, if we choose a region, let's say Frankfurt, and if we deploy our microservice, our Lambda, it will be automatically deployed across many different data centers. So it's automatically highly available. So we don't need to think about this anymore. The third rule is it needs to scale automatically. The scalability is one of the rules of the cloud. We can create auto-scaling groups. We can say, I want to have 2 servers. Maybe in 2 hours, I want to have 200 servers. But again, with serverless, it needs to be easier. And in short, when I will deploy my microservice, and if there will be one user who is consuming this application, there will be one microservice. If there will be a couple of users, what the cloud will do, it will spin up multiple instances of this microservice, so all of those users will be able to access this microservice in the same time. But maybe there will be thousands of them, so then we will have got thousands of those instances, and this again will be done automatically. So that's why it's just easier to build application in this kind of approach. The last rule which I would like to mention here is about we don't want to pay for the idle time. This is especially important for startups. Maybe we will build this new Netflix, but maybe we won't make it, okay? And if we won't make it, we don't want to pay for this. And with the serverless approach, with this microservice on Lambda, it's like this, that if there's nobody wants to execute our Lambda, our microservice, there are no instances. because it's sleeping. And if there are no instances, we are not paying for anything. Maybe this is the middle of night, this is 2 a.m., everybody is sleeping, so we won't pay for anything. If suddenly somebody will wake up and he will want to call our microservice, our Lambda, it will wake up, it will do what was the program there, and then it will fall asleep again. So where to use this kind of serverless Lambda services. In fact, there is multiple different ways how we see that companies are using this. One of the most popular cases is to build backend application using this kind of approach. So let's imagine that we're building a mobile application, thanks to which our users will be able to register and to get information about promotions. So we have got some front end, which is on the mobile. They provide their name, their email address, and they press the button. So now we need to have some backend, okay? So we need to have a database, and we need to have a logic which will be responsible for getting the data and saving it in database. So with serverless approach, it will take about 5-10 minutes to build this application. So in short, we will create one Lambda function. Let's call it promotion registration. So now whenever the user will press the button, the request will go to our Lambda, to our microservice, and this microservice will be responsible also for saving this data somewhere. So maybe let's also have a serverless database. In this example, DynamoDB. So serverless is not only about functions. Most of you should be familiar with something which is called IaaS, PaaS, SaaS, so infrastructure as a service, platform as a service, and so on. There is also something which is called function as a service, and Lambda will be an example of this kind of approach. But serverless is a broader topic. Only in AWS, there is about, I would say, 10, 15, maybe 20 services which are serverless. S3, for example, which is a simple storage service, is serverless. IoT, identity access management, and many others are serverless services because we don't need to manage about the infrastructure. It will scale automatically, and if we are not using it, we don't pay. So, for example, API Gateway. API Gateway is a service thanks to which we can expose our backend, our Lambda, for example, as a RESTful web service. So we define our domain, we define some kind of resources, and now whenever the user will send some kind of HTTP method, like get, post, and so on, it will be sent forwarded to our application, which might be built using Lambda. Another example will be DynamoDB, so NoSQL database. We want to have a NoSQL database like Mongo, like Cassandra, but we don't have expertise in how to manage this, how to scale it, and so on. So we just go to the cloud. We say, I want to have a NoSQL database, and in short, in 10 minutes, we have got it, and we can start using this. And depending on the number of data which we have got, number of throughput which we want to achieve, then number of shards, so the infrastructure will grow and will shrink. So we will go through other examples in a couple of seconds when we'll start to build application. Another topic which I would like to address here, because we will be also using this on the demo, is artificial intelligence. And artificial intelligence is one of the hottest topics now among all companies. Everybody wants to build smart application. If you have application which is using artificial intelligence, it's really good. Everybody are interested, and so on. And there are different ways how you can use artificial intelligence. Some companies will have got expertise. They will want to play with TensorFlow, with Apache MXNet, and so on. And they will go to the cloud and they will choose those Lego blocks, those services, thanks to which it will be a bit easier to build those applications. Some companies, some startups and so on, they don't have expertise, they don't have time to learn, so then they will go to the green box. So those are the services which provide some specific artificial intelligence functionality to the user. So there is API, and we can consume it and to get this artificial intelligence functionality. One of the examples could be Poly. Poly is text-to-speech service. So in short, we provide text, which can be in many different languages, and we will get audio based on this. What is interesting is that this service was built here in Gdańsk, so something which was built by us. Another example, you may be familiar with something which is called Alexa. Alexa is artificial intelligence, which is inside of this device. This is Echo, this is Dot. So in short, when you will say her name, Alexa, it will wake up, it will listen what you want to do, and it will try to find the answer on the internet. And based on this technology, what AWS have done is it's created a service which is called Lex. And in short, Lex will be a service thanks to which we'll be able to create chatbots. Another example, Amazon Recognition. So the service which we can consume and we can use it to analyze images. What is on the picture, who is on the picture, is it a celebrity, and so on, so on, so on. Okay, so those were the slides. Let's finish at this moment with the slides, and let's try to build something. So, in short, I have two applications which I would like to build. I don't know if I will manage, but let's see. In short, the first application will be like this, that at the end, I will provide you with the link. I will ask you to open this link, and at the end of this link, you will provide a text. A text which will be then forwarded to the cloud. So I will create a RESTful web service using API gateway, and this parameter, this text which you will provide, will be forwarded to my microservice, which will be a Lambda service. This Lambda first will try to detect what language did you use. Polish, English, and so on, and it will detect based on another service which is called comprehend. So it will send their text, and as the result, we will know what language did you use. Then, knowing which language was used, we will use Poly to convert this text to audio, okay? And then we will also log this information in DynamoDB as, who did when, and so on. The next step will be that we want to save this audio file somewhere. So we'll use S3, so Simple Storage Service, to save this MP3 file there. And then we'll just generate HTTP response, so the page, to the user, so the user will be able to listen to the text which he provided. So he provided something, and he will see the play button, and he will listen what he provided. Also, if the user has provided his phone number, then the Lambda function, what will do, it will send SMS to this user saying, okay, under this link, there is your MP3 file, you can listen it, you can download it, and so on. Okay, is it clear? Okay, I have got only 20 minutes, so let's try to build it. For those of you who don't know, wait. I see my screen, you don't see it, so wait. Okay, let's go maybe like this. Okay, so this is AWS Console, so this is the way how we interact with AWS, and we're using those Lego blocks to build an application. So in this case, oh wait, I need to see it, otherwise it won't make sense. Just give me 1 second. Okay. Okay, so we have got AWS Console. So first thing which I will need to have is the DynamoDB. So I want to log this information in NoSQL database. So I will go to this Lego block DynamoDB, and I will create a table. So NoSQL database, in this case, this will be a table. I will call it Infoshare, and this is NoSQL database, so I don't define the schema, but I need to define what is the primary key. So let's say that the primary key will be ID. And let's create our NoSQL database. This is serverless, so I don't need to define how many servers do I need, and so on. And in short, in 5 seconds, it will be there. Okay. The next step, the next thing which I will need to have is S3. I need to have a place on S3 where I will save my audio files. So this is S3. Those which you see, those those are buckets where I can store my information. So I will create a new bucket. I will call it A Infoshare test 1, and let's create it. Okay, so I've got my bucket. Here I will save my audio files. Okay, cool. So I will just open another tab. Okay, so the last thing in short will be Lambda, because the Lambda will be the most important thing in this demo. So I will go to the Lambda, and I will create my function, my microservice. So I will call it info converter. I will call it Infoshare. Like I said to you before, we can choose a couple of different languages. In this case, I will use Python 3.6, and the role will be the permission. So this role, this Lambda will have got access to everything in AWS. So let's create this. Okay, so this what you see here, this is the most important part. So here we can provide the text, the code of our business logic. So I have prepared this before. I didn't want to risk to write it now. So I will show you how does it look like. Okay, wait a second. Okay. There's nothing fancy here. In short, I'm able to, without mouse, it's really hard on Mac, sorry. Are you able to see the code, more or less? Okay, guys. So in short, first I'm checking if the user provided text parameter. So HTTP parameter, the query parameter text. If yes, then I'm using the comprehend service. I'm providing there the text which you have provided, and I'm getting the language which was used, in which the text is written. Then I'm connecting with Poly, and I'm saying I want to create MP3 file based on the text which was provided, and with the language, with the voice which I already detected. So at this stage, I have got my audio file, my MP3, and here I'm connecting to S3. I have got a variable which I called bucket, so this will be the name of the bucket where I want to save my audio file, and I'm saying upload file in this bucket and make it publicly available. And then what I'm doing at the end is I'm connecting with DynamoDB. So this is my NoSQL database. So I will need to provide its name. So now it will be DB name. And I'm saving there a new record with a couple of different attributes. ID, text, which was provided by you, language, voice, link to the file, and so on. And then I'm doing something which is not the best practice, but for the purpose of this demo, it's okay. I'm generating an HTML response, okay? And there's a player, thanks to which you will be able to to push play, and you will be able to listen the audio. And also, if you have provided your phone number, I'm using a service which is called SNS, so Simple Notification Service. And in short, I'm sending you SMS with the link to the audio file. And if you didn't provide the text parameter, I will tell you you need to provide the text, okay? And this is my Lambda function. So what I will do also is I will increase the timeout for 30 seconds. So my Lambda should take less than 30 seconds to complete. Okay, so let's save it. And like I said before, we have got two variables. One was the name of the bucket, when I want to save the files. And the second was the name of the NoSQL database. So this is the DB name was the name of my NoSQL database. And this was, I guess, Infoshare, yes? So this was the name of my NoSQL database. Okay. And the second parameter was S3 bucket, so which was here. Okay. And the name of the bucket was A Infoshare test 1. Okay. So let's save it. And at this stage, my microservice is ready. But now I also want to expose it as a RESTful web service. So in short, I will add a trigger, API gateway, which allow us to expose this microservice as a RESTful web service. And I will configure it. So before already I have created an API which is called Infoshare, so I will just use it. I will say that this is production and the security is open. So everybody will be able to access this API. And let's add it and let's save it. So if now I will access this endpoint, so I see here the endpoint, I should see the message which was, so you need to provide the text, okay? Because I didn't provide the text parameter. So at the end of the link, I will just add question mark, text, this is test, okay? Maybe I should record it before. This is test. Okay, it's not working, so let's see why. So we will go to monitoring and we will see in the logs what's happening. Okay, so the logs are being captured by the CloudWatch, which is a service which is capturing the logs. So wait us 1 second. Okay, I know what's wrong. So I was using Python 3.6, and my code was in Python 2.7. So I'll just change this, save. Okay, so we'll try to execute it again. So now it's doing something, and I see the player. So let's click on it.
This is test.
So it's working. If I will provide something else, so in Polish, for example,
To jest test pierwszy.
so my microservice, which is using the comprehend poly, is working and is detecting the language and it's creating the audio. So I would like to ask you now to test it. Showing short this API is also available under this domain. So HTTPS. So if you could test it, HTTPS api.demo cloud.pl test Infoshare. And in short, if you will provide then the parameters, so the text, it should, don't write anything bad, okay? Because I will show you, who wrote what. So just don't write anything bad, please, okay? Is it working? I would also try to test it. It's not working. And if you will provide your phone number, and it will look like this, so there is the second parameter, you should also get an SMS. If you will be providing your phone number, don't forget about the country code. So for Poland, this will be +48. It's working? Okay, so let's see if we are able to see it first of all in S3. So if I will refresh the page, I already see that number of people were testing it, okay? So those are the audio files. If I will go to DynamoDB, I will be able also to see the log information. So let's go to my table, to items, and here I have got those information. So quite a lot of people tested, thanks. So yeah, pozdrowienia, ABC, test, siemanko, Opera sprzedam, and so on. So we have got information also about the user agent, the voice which was used. So most of it is in Polish, so that's why we have got the Maya. Okay, is it clear? Okay, we have got, I guess, 20 more minutes, so I would like to show you I would like to build another application if you don't mind. Wait. Okay, in this application, we'll be using a completely different services. So in short, I have built a web application. It's nothing fancy. It looks like this, okay? It's an application where you provide your name. There are boxes on which you clicked. So in short, what I will ask you to do later is you will open the web page and you will provide your name and you will start clicking on the boxes. And I will start collecting those information, which colors did you click and so on, using a serverless service which is called Kinesis Firehose. And this is, for those of you who know Apache Kafka, so this is something similar, but this will be serverless. So in short, we don't define how big the stream will be. It will just get bigger. It will get all the data. And if we are not sending any data to the stream, we are not paying for anything. So the Kinesis Firehose will detect the data, will collect it, and then it will send it to S3, where we will have got all of those information. But this won't be the end of our application. At the end, we will also want to gather some insights about this application. And we will want to talk with our application using Alexa. So with the dot. So we will try to build a skill. So if we're using Alexa, in short, we're building something which is called a skill, which is an application which we can execute by its name. So then we'll call Alexa asking which color was the most popular and so on. And then what Alexa will do, it will send the input, the request, to our microservice, to our Lambda function. And Lambda, what will do, it will try to validate, to test the data which we have collected with a service which is called Athena. Athena, for those of you who don't know, the simple way how to describe it will be it's a serverless Hadoop. So underneath there is a Presto, there is Hive. We don't define how big the Hadoop ecosystem will be. We just provide the SQL query. We just say where the data are collected, and based on this, Athena will check the data which we have collected, will provide the data, the result to Lambda, will send it back to Alexa, and will be able to listen, which color was the most popular or who clicked the most. So this is the application, and it's accessible under this page. It's not working because we need to build it, but you can access it. And the thing here is that the person who will click the most, in short, will win a prize of $100, okay, or for AWS. Okay, so let's try to build it. We have got only 15 minutes, so let's build it. Okay, guys. So first of all, what I need to have Kinesis Firehose. So this will be the stream which will be collecting all of the data, and then it will be saving this data on S3, okay? So let's go first to Kinesis Firehose. So all of the services which we are using today are serverless. So we don't define how big infrastructure do we need and so on. So get started. We need Kinesis Firehose, so the stream. Let's call it Kinesis Firehose, and let's go next. I will just make it a bit bigger. So we don't need to transform the data, so we'll just skip it. And we are saying, yes, we want to store the data on S3. And where on S3? So let's maybe also create a new S3 bucket where we will be storing the data. So let's create a new bucket, a Infoshare test2, and let's create it. Okay, so this is the bucket where we will be storing the data. Okay, so let's say, yes, that we want to save the data in this bucket, and let's go to the next step. So Kinesis Firehose, what it will do, it will wait, and when it will have got at least 1 megabyte of data, then it will save the data on S3, or if it was already 60 seconds after the previous load to S3, okay? So in our case, probably after each 60 seconds, it will take the data which it collected, and it will save it on S3. Okay, we don't want to compress it and so on. We will also need to create a role. A role is a permission, so we need to allow our Kinesis Firehose to have access to S3. So let's create it, and let's go next and create deliver stream. It should take about maybe 30 seconds, and after 30 seconds, we'll have our serverless stream, which will be able to collect the data. Okay, so let's refresh it. Still being built. So I will just go to my own application. So this was www.democloud.pl. So it looks like this. I will just also open the JavaScript console, thanks to which we'll be able to see the interaction between the front end and the back end. So, okay, I will provide my name. I will click on red, and I have got a bad request. So probably my Kinesis Firehouse is still being created. Okay, so to not waste time, we'll also go now to Athena. So Athena, like I said to you before, this is this SQL engine, thanks to which we can execute SQL queries on the data which we have collected on S3. So the way how it's working is really easy. In short, it's using Hive. So first of all, we will define where our data is stored, and then we'll just execute SQL query. So I have already prepared something, so this will be something like this. So my data, which I'm collecting, is in JSON format, and there are two values. The first value will be the author, so who clicked, so the name of the person, and the second will be the value, so the color. And I need to say in which bucket, where on S3, I'm saving the data. So in my, I don't remember the name of the bucket, so let's go back there. So okay, so this was a Infoshare test 2. So okay, so and let's create a table which we'll call Infoshare. So let's run query. Okay, so we have got our table. Probably now it's empty because we didn't start collecting any data yet, so it's 0. So let's go to our application and let's see if it's already working. So I will just refresh the page. So I will write my name, and let's click red, and still not working. Okay, still creating. Usually it's faster, but okay. And 10 minutes, okay. So the last thing which we will need to have in our application is the Alexa integration. So in short, when we are building skills, so those applications for Alexa, we are using a different portal. This is not a part of AWS, and to use it, there is a developer amazon.com, which is completely different portal. And there we can go and we can create those skills. So I will just go here, and I have already created, probably yesterday, something which I call demo application. So I will go to this demo application, and I will show you how does it look like. Okay. So how to create a skill? In short, it's really easy. So first of all, we need to provide the name of the skill. So in this case, let's call our skill my application. Okay, so now if I will ask Alexa, ask my application, because this is the name, which color was the most popular, it knows that it should execute this skill, this application. Then I'm creating something which is called an intent. So what is the intention of my skill? I want to have two information. I want to gather two information. First of all, which color was the most popular and who clicked the most. So I also provide two values, how the user can ask for this. So for the color, he can ask which color is the best, or maybe he will say which color or maybe something else. Based on those values, Alexa will also try to detect what are the other ways how the user can ask for this. And for the author, the way how I programmed this is who clicked the most, which author, who's the best, and so on. Okay, the last thing here is the endpoint. So I want to integrate this skill with my microservice. So here I will provide an ID of my Lambda microservice. So let's maybe see if my Kinesis stream is created. Okay, it's active. So let's try to see if I'm able to collect some data. So my name is Tomek, and let's click on something. So now I see in JavaScript console that I'm getting no the error message, but I'm getting some kind of identifier from Kinesis saying, yes, I got your request, and this is the ID of it. So I will click on something more. So let's say I will click on red. Okay, and so on. So now Kinesis is gathering this data. It will wait 60 seconds, then it will save the data on S3, okay? So let's also wait this 60 seconds to test if it's really working. So what we're missing for Alexa part is also this Alexa microservice. So the thing which will be connecting the device and with Athena. So let's go and let's see if I already have it. If not, I will create it. So Lambda. Okay, I don't have it, so let's create quickly. I will use a blueprint. This will be just easier. So I want to use Python. Echo. Okay. No, sorry. Python, Alexa. Okay. So I will call it Alexa into Infoshare. Okay, and the role again, the permission will be the full access. So this Lambda will have got access to everything, and let's create our microservice. So okay. It's here. So now I also need to provide the code. So I will show you the code. It's a bit more complicated by the part which is interesting, the most important. It's not so complicated. So what is important that this code, this microservice will be executed whenever this Lambda, whenever Alexa will see that I'm calling my application. And here I'm saying, see if the intent was the most popular color. If yes, execute the method which color. If it was something else, so the author which was the most popular, execute which author. And here I have got two methods which are not very nice, but it's working. So in short, in those methods, I'm executing SQL query. I'm saying select author and count from and the name of my table, which I called Infoshare. So I will just replace this with Infoshare. And also here. So in short, the standard SQL query will be executed. It will get the data. It will provide it to return it to Alexa, and it will be saved. OK, so let's save it. And I also need to have this ID of this Lambda, so I will just copy it. I will go back to my to this Amazon developer Amazon portal, and I will provide that the backend of this skill is my microservice. OK, so let's save the endpoint. Let's save the model, and let's build it. It will take about 30 seconds, so let's wait. Let's go to S3, and let's see if the data which we are collecting are being saved here. And I have got, OK, a new folder. So let's go. This is the date. And I see that the data which we are clicking are being captured and being collected here. So if I will go to Athena, and if I will now go to the preview table, I should be able to see that somebody, at least me, are sending the data. So JZ, which color he clicked, and so on. So I could do a bit more complicated query here. So for example, let's see the query which I provided in my Lambda. So for example, which color was the most popular? If I will copy it, and if I will execute it here, I should be able to also see the result. But OK, my browser is dead. OK, so the blue was the most popular almost 500 times. OK, so let's go to Alexa. So it's already built. So first of all, let's test my skill from the web browser. So let's say which color, ask my application which color is the most popular.
There was a problem with the requested skills response.
Okay. 3 minutes. Let's see if we'll be able to fix it. So let's go to monitoring. Let's go quickly to jumps. And let's see what was the problem. Okay, I think, to be honest, that I won't be able to fix it in 1 minute, but you see I guess you see the point where I was going, okay? So in short, the thing was here that I was going to say, Alexa, ask my application who clicked the most.
There was a problem with the requested skills response.
But in short, my microservice was executed. Maybe I made some mistake there, but in short, it would work. It would connect. It would analyze the data which we have collected, and it would take the data. So just to be fair, so let's see who clicked the most. So let's see the code which was responsible, the query to see who clicked the most. If it was Jay-Z, I will ask you to show me your ID, okay? If it's saying Jay-Z, then you will get $100. Okay. Let's run it. And in short, Jay-Z was the most popular. He clicked 600 times. But the person who was Jay-Z can come in the break to me, and I will be fair and I will give you this voucher. Okay, guys, so in short, this is the end. I have got 1 minute. So I hope I show that in short, how we see this is the way how people are building applications. They are using those serverless approach to build those applications just faster, okay? We can use something which is already existing in the cloud, some already existing services, and we can build not the easiest application in 10 to 15 minutes, okay? Cool. So thanks for the session. If you will have got any questions, I will be outside of this room for a couple of more minutes. Thanks.